Okay, this is a video to finish the back of 4.4, and we're going to actually talk about what we call special cases. And just like when we were solving equations, you saw some that had now it said infinitely many solutions, and then also no solutions. So we're going to be looking at the exact same thing. So I want you to write down, so when we solve system of equations, if your final product, if your final information at the final line turns out to be a true statement, then it's infinite solutions. Okay, which means, so example, if it comes out to like 1 equals 1, well, that's a true statement. So then that final answer would be infinite solutions. Then a no solution would be a false statement, just like we had when we were solving equations. So false statement. So the example, if you had like 2 does not equal 7. Okay, so if you came out to 2 equals 7, then that's a false statement. When these happen, what you're going to notice that both variables are canceled. Okay, so what's going to happen is, ignore that. That's a note to me when I was doing it live with you guys. So anyway, both variables are canceled. That's what happens when either one of these. Okay, so let's talk about the solving system by elimination. Given special systems. So again, with elimination, we want to see if we can get opposite coefficients. Well, looking at these, we have 4 and 6 and 6 and 9. So notice one's positive, one's negative, so I do like that. But I'm going to go ahead and go for, you can go either way. The least common multiple is 12. Now you could do it also 24, but I'm going to go ahead and do 12. So I can multiply this by 3 and that by 2. Then I'm going to get 12x plus 18y equals 24 minus 12x minus 18y equals a negative 24. Well, look what happens here. So what happens is both of these terms, negative 12x minus 12x, well, that's 0. 18y minus 18y, that's 0. And 24 minus 24, well, that turns out to be 0 equals 0. So that is a true statement. So this is going to be infinite solutions. Okay, so basically what happens is when the x and y variable both get eliminated, you're either going to come out with an infinite solutions or a no solutions. So let's try this one. Opposite coefficients does not happen. 9 is not a multiple of 2, or 2 is not, 9 is not a multiple of 2, 27 is not a multiple of 6. So we can force it, and that's both addition, that's both subtraction, so, or positive and negative. So I'm going to go ahead and just do negative 9, positive 2. It doesn't matter, but just don't do both negatives when you're multiplying. So I'm going to do a negative 18x plus 54y equals a negative 72. 18x minus, 54y equals 36. Okay, that's a negative 72 and 36. So then these are opposite. So this turns out to be 0 on this side. But then negative 72 minus 36 is a negative 36. Well, 0 does not equal a negative 36. So this is a no solution. So what's going to happen is, if these were graphed, a no solution, these would be parallel lines. If you graph these, that would be parallel lines. They will not ever intersect. That's why it's a no solution. They don't have any common ordered pairs in common. This one, infinite solutions, if you graphed it, they would be the exact same line. Exact same line. So if we had to graph these two equations, they would be the exact same line. These two would be parallel lines, no solution. Okay, so let's try 3 and 4. So first off, look at 3. Watch how this is written. This is not in standard form, that second equation. So I would rewrite that in standard form. So you have 2x plus 4y equals 6. Then you have 3x. Now you got to bring the negative 6y over to the other side. So you're going to add 6y equals 12. Get them in standard form first. All right, then neither one's opposite coefficients. So I like to multiply the lowest number possible. So I can do 6. So I can do 3 here and a negative 2 there. Or you could do a 6 and a negative 4, or a 3 and a 2. I mean, you have possibilities. You know, a lot of different possibilities here what you multiply by. My goal is to get the opposite coefficients. Which you could be doing this. Okay, so that's going to be 12y equals 18. Negative 6x minus 12y equals negative 24. Okay. Then these two cancel. That's 0. That's 0. So that's going to be 0 equals, what is that, negative 6? No, positive, yeah, negative 6. Okay. Which is a no solution. Okay. So no solution. This one, it's already in standard form. So I'm going to do maybe the 5 and the 2. You could do 30 here. The least common multiple of both of these, of 6 and 15, would be 30. But that's okay. I'm going to do, that's opposite. So I'm going to do 5 and 2. So 10x minus 30y equals 60. Negative 10x plus 30y equals negative 60. Okay? Now, if you notice, when they're opposite coefficients on both, you automatically know it's either going to be a no solution or infinitely many. Then notice this. These are just opposite here, so that's going to be 0 equals 0. So that's a true statement. So when it's true, that's infinite solutions. I've always wondered why when we have one equation, we call it infinitely many solutions. And then when we do systems, we call it infinite solutions. So that's just something I'll look at. But that is what you will see. Now, another little symbol, I want to show another little symbol that you might see in our project that we're going to do. A no solution, you might see this symbol, meaning empty set. Sorry, empty set. So you're going to see that solution, that icon, well, I don't know, symbol. And then on a solution that or activity that we're going to do, you might see this, the infinity sign. Not all real numbers. A student asked me about all real numbers. Sorry, not an LY, but you're going to see an infinite sign, okay? On the project that we're going to do with practice of solving systems equations. The reason you can't say all real numbers is because not every single number is a solution to these. Okay, so it's just different because they are going to be the exact same line. They have all the solutions that they have in common, not just one of them, but not every single ordered pair would work. Okay, so that's what I just want you to watch for 4-4, and that are your note taking, is your notes for today. But take a look then at the next project we're going to do.